Hello, everyone. Thank you for coming to this session on Android accessibility. I have three of my colleagues with me. I am TV Raman. I lead our work on Android access. With me, I have Alan Viverette, Charles Chen, and Peter Lundblad. And what we are talking to you about is accessibility on the Android platform in terms of what Android does for you with respect to increasing the breadth of users that you can cover with your applications. So, you've heard talks all day today in terms of how Android does a lot of heavy lifting for you so that you as an application developer can focus on the logic and functionality of your application. So, today you don't need to worry about, am I writing for it? Small phone, big phone, tablet, Android does all of that work for you. What this talk is about is giving you yet another perspective on the huge variety of devices and users that you address when you build an Android application. I use speech for all my work, I cannot see. My colleague Peter uses Braille for all his work. And what we are showing you is APIs in the platform that actually allow us to build accessibility services that let us use all of the applications you guys are building in manners that you would never have thought we would use it. So, that's really our motivation here with Android accessibility, is to increase the reach of these applications to users with different needs, with special needs. We've come a long way since our access work on Android started in 2008. A quick history tour for you in terms of how we've evolved and what the platform does. So, our access work actually started in Android 1.6. 1.5 we released the text-to-speech API, and 1.6 basically allowed users to navigate using system focus, and anything that you navigated to would speak. And you could use a lot of simple applications that way. We have since come a long way, and in Ice Cream Sandwich at the end of last year, we released a feature we call touch exploration, which then allows me as a blind user to touch different parts of the screen and hear what is under my finger. This basically then completely opens up all aspects of the Android user interface to a blind user, because now with touch exploration, you could actually read everything on the screen, not just things that were focusable. And that was a huge step for us. But what we had as a gap in ICS, which we are now covering today, and we'll talk about this in greater detail, is the next step. So, that was the short history lesson. Let's talk about Jelly Bean, right? So, there are significant access API enhancements in Jelly Bean. Some of you heard a quick overview of this during Raman talk this morning. We've done a series of things that actually enable both spoken feedback access for blind users as well as Braille, which Peter will show you in a bit. But at a high level, here are the three things we are introducing today. We have introduced the notion of accessibility focus in Android, which Peter will talk about in detail, that allows blind users to reliably step through the interface. So, accessibility focus is something that can be put on any part of the user interface, and as a result, what is there will speak. We have also introduced this notion we called accessibility actions that you can then trigger from accessibility services like TalkBack and BrailleBack, which Peter will show you. What those actions let us do is we can then perform clicks and selections and things like that programmatically, which then allows us to hook up esoteric devices like Braille displays and other keyboards and whatever you can imagine. And finally, we have introduced a set of gestures, this was mentioned during the keynote today, that allow us to then bring together accessibility focus and access actions to allow a blind user to very effectively use the Android user interface. And last but not least, the other major enhancement in Jelly Bean is the coming of age of Chrome, and the Chrome browser is completely accessible in Jelly Bean. And it all works seamlessly, as you shall see during the various demos we have for you. So with that, I'll hand off to Peter, who's the lead engineer behind BrailleBack, which is our Braille, which is the Braille enablement of the platform. So BrailleBack is an accessibility service that uses these same APIs that I've been talking about to basically provide a Braille interface on Android. So Peter, go for it.
Thank you, Raman. Hi, everyone. I'm Peter Lundblad, and I'm going to, as Raman said, talk about a few things. I'm going to start talking about one of the things that we've added in Jelly Bean that enables things like BrailleBack and other things for the user. And this is called accessibility focus. It allows a user to interact with anything on the screen, like any view. It behaves similar to a cursor in the sense that you can move it around on the screen. It is also similar to input focus, but the difference is, as I said, that it can interact with all views, which is great, because input focus can only reach views that are meant to be, for example, take input. So a good example of that is an edit text or a push button that you can press enter on, and then it will activate the button. But for a blind user, you want to be able to read anything on the screen, including static text and similar, which is normally not focused by input focus. So therefore, we added this accessibility focus that is shown on screen as a yellow rectangle. Accessibility focus can be placed anywhere by the accessibility service, and this allows multiple modes of interaction. It's handled by the system, which means that there is one global source of truth. But again, accessibility services get notified when it moves, and they also have control over it. So how can we, what are these examples of these multiple modes, different modes of operation and interaction by the user? How can we move accessibility focus? One example, as Alan is showing, is by swiping on the screen. Alan will actually show you later on more about these swipe gestures that we've added. Another example is that the touch exploration that was already added in Ice Cream Sandwich now moves accessibility focus. We are also able to move accessibility focus by accessibility services using, for example, a Braille display, which I'm going to show you in a bit. The great thing is that when one accessibility service moves the accessibility focus, it gets broadcast to all accessibility services. So for example, if you have TalkBack and BrailleBack running on the system at the same time, they get synchronized, and the user knows where he is by both Braille and speech. Now, being able to only read what's on the screen is great, but life is pretty boring if you cannot interact with anything. So that moves us over to the next part, which is accessibility actions. Accessibility actions allows a user to interact with nodes in different ways. And that's very important, because if we now have the different ways of moving around a focus, then you don't really know where on the screen the different views are. So therefore, you also need to actually do things with them. So what accessibility actions do we support? Yeah, the obvious thing is moving accessibility focus, as I already mentioned a few times. We can also move input focus, which is useful, because then we can, at will, as an accessibility service, synchronize the two focuses when that's good for the user. We can click on views, which of course is the most used action, so that we can activate buttons, activate input fields, and so on. Another important thing is that we can scroll on the screen. So if if the view has more than one page, we can move between them. That's already possible using swipe gestures on the screen, but a problem for blind users is that it's hard to scroll exactly by one page. And then if you don't do that correctly, then you lose where you are in a list box, for example. So the new actions allow us to scroll discretely. There's also actions to move inside of text. So if you have a text view with lots of text, maybe you want to, as a user, read it by character, by word or paragraph. Or there is actions for handling moving inside WebViews. And all these are called, movement by different granularities. We also added something which I'm not going to talk much about. That's called global actions. That does allow things like activating the home screen and pressing the back button and going to notification and so on. This is something that is purely handled by the system, and application developers don't have to worry about it all. So the great thing with accessibility focus and actions is that most of the time they are handled by the system as well. But there are occasions when the applications need to worry. I'm going to show you some code examples before we are going into the demo about how this can look. If you have a very simple view, like on the first code example, that just adds an on-click listener, I think this should be familiar to anyone who has done any Android app development. If you have this kind of view, that is already totally handled by the system. Because by default, the action on-click that allows us to perform clicks from Braille displays, for example, is calling the on-click listener, and that's it. Now let's look at the second code example, sorry. And there we have a different kind of view. This view is a bit more low level. It's a custom view where we handle touch events directly. So we have an on-touch event listener handler, and that will be called whenever there is a touch event. And the view will directly respond to touch event and call some internal function of itself. So it's not going through the on-click listener. This obviously won't work because the system won't know what function to call when an accessibility server invokes an action on click. So we have to fix that issue because otherwise the user won't be able to click on this view. One way is to refactor the view, of course, by invoking the on-click listener and then letting the default action handle the situation. But if that's not possible, sometimes you don't have access to your view, or maybe you can't easily change the code, then it's possible to inject something that we call an accessibility delegate. That allows you to take care to externally from the view handle the accessibility actions and other calls that are related to accessibility. And in this last code example, we are doing that to take care of the on-click call by ourselves and call our internal function, and that will fix the problem we had on the previous slides. Now, depending on what kind of view you are creating, we might have to add handling for other actions as well. For example, if there is scrolling support in your view, you might need to handle the scroll action. It's also important to remember to call back to the superclass if you don't handle the action yourself. So, what can all these additions be used for? We are adding something new, or the new features of the platforms enable us to add Braille support. Sometimes blind users prefer to use something called an refreshable Braille display. And this is an alternative way of interacting with the system. We are enabling a number of different Bluetooth-enabled Braille displays to connect to Android phones. A Braille display has a line of so-called Braille cells on them with dots that can be raised. and the user can read on that line. There are navigation keys on the Braille display, so that since it's only one line, it's possible to move it around on the screen and move around in the user interface, activate things, and so on. Another thing there is usually on a Braille display is a corded keyboard, so that you can also input Braille. And if this makes it much easier to type text than if you're using a touch screen. Of course, sometimes using the on-screen keyboard is the only alternative, but if you have the Braille keyboard, it makes life much easier. So we are adding this accessibility service, which is connecting via Bluetooth to the Braille displays. It uses the accessibility events and nodes in the node tree to know what is on the screen and present that to the user. It synchronizes with TalkBack using accessibility focus. So depending on which ways you are, so you can actually interact with the system in many ways at the same time. You can use TalkBack or you can use Braille, but they will both be synchronized. In addition, we're adding an input method so that you can actually enter text using the Braille display. This new accessibility service is called BrailleBack. It's available on Google Play Store today if you're running Jelly Bean. So please try it out if you happen to have access to one of these hardware Braille displays. I am now going to do a little demo. And as we all know, sometimes wireless technology can be difficult. So let's see how this works. The first thing that can happen is that a Braille display is disconnected from the Android device. So what we wanted to make it so simple as possible to reconnect to the Braille device, or actually if you have disconnected it for battery reasons. Therefore, we'll have to. So what the user then does is lock the screen and unlock again. And I'm going to ask Alan to do this for me today, so that we get the display connected.
Screen off. 12:30 a.m. Ring a 7 slide home screen 3.
And there we heard a little sound, and that made the Braille display actually connect. Unfortunately, though, it is not so. As I mentioned, the wireless is not always our friend. So I'm going to try this once more.
12:31 a.m. Ring a 70%.
We might have too many radio waves.
To minimize interference, if you have Bluetooth turned on, if you could turn it off, we would appreciate that.
OK, so this is now working.
IO 2012 WebView tutorial.
OK, so let's look what I can do here. So as you can hear, the speech is talking. I can now use the keys on the Braille display to move around on screen. So let me do that.
Home screen 3.
It says home screen 3, and as you can see, the accessibility focus is moving to focus the whole screen, and the speech is also talking.
IO 2012 WebView tutorial 031. Google I/O 2012.
Let me invoke one of the actions I talked briefly about before, and that's the action to open the notification window. I do that by pressing a key combination on the Braille display.
12:31 Thursday, June 28th, 20. Screen will rotate automatically. Checkbox. Orientation set to portrait. Clear notification button.
Here, I go to the
Alan Viverette, June 27th, 12. Hey, want to get a coffee?
OK, so Alan is asking if I want to get a coffee. That's great. Let me respond to that chat. What I also have on the Braille display is a row of small buttons that easily lets me click on anything that I have focused on the display. So I'm going to click on Alan's chat message.
Edit box, type message.
That takes me right into the edit box in Google Talk, as we expect when you click on this notification. I'm going to move upwards on the screen to see what he actually said.
This chat is off the record. Hey, want to get a coffee?
As you can see, he's concerned about privacy, but he still wants to have some coffee.
This chat edit box, type message.
I'm going to type a response.
Y, E, S. Yes, I, L, O, V, 3.
OK, making a typo. I can easily fix that.
3 deleted. E, love. C, E.
All right, so I have written I've typed a response. I can use the small keys I earlier mentioned to move around on the screen. Sometimes.
This edit box. Yes, I love coffee.
Okay, so I have now, I'm going to press the button to actually send
this chat is off the edit box. Yes, I love coffee.
And there you see that I can actually send a message, and it now appears in the chat list before. I'm going to invoke another global action that we have that's very convenient, and that is a key combination again on the Braille display.
Home screen 3.
That takes us back to the home screen. And with that, I'm going to hand it over to Alan, who's going to talk about touch exploration. Thank you.
Thank you, Peter. I look forward to getting that coffee later. So as we showed, you can use your finger to explore the screen. So you can set accessibility focus by touching your finger to the screen, as you just heard. This provides random access to on-screen content, which is really great if you're familiar with what the screen looks like. So somewhere like the All Apps screen, you have a lot of buttons, and you can find things pretty quickly. And you can now double tap to activate the item that has focus with absolute certainty that what you just heard is what's going to be launched. Now, this is great, but having some deterministic way to access items on screen is even better. So let's say you have a really big screen with one little button. I can move my finger around for a long time and never find that button. But if I can touch my finger to the screen and just swipe to the right to go to the next item, I can find that button very quickly. And in fact, I can just keep swiping right to go through every single item on screen. So we've added these swipe gestures that I demoed earlier when Peter was talking. And we've also added gestures for global actions. So Peter showed you home on the Braille display. You can also draw a shape on the screen to go home. We also sort back recent applications and notifications. And an accessibility service like TalkBack or BrailleBack can also use gestures to manage internal state. So in TalkBack, we have a gesture that you can use to start reading the screen by word or character instead of by object. So here's a quick overview of the gesture mapping that we have in TalkBack. You'll see there are a lot of gestures. And in fact, these aren't all of the gestures. We've left a little bit of room for experimentation later on. So let's do a quick demo for Explore by Touch. All right, so first I'm going to start with touch exploration. So
home screen 3, apps, home, showing item 3 of 5.
So I can look through my apps,
maps,
random access by moving my finger, or I can swipe left and right if I know that what I want to find is probably a little bit past maps. So
messenger, navigation, people.
OK, so if I want to launch people, I can just double tap anywhere on the screen.
All contacts drop-down list.
And I get contacts. So if I'd like to go back, I can draw a back gesture.
Apps.
Let's go back again.
Home screen 3.
And let's take a quick look at the Google I/O app.
I/O 030 Google I/O 2012. Google I/O 2012. List showing 1 items.
Here I have a list of items.
Showing items 1 to 3 of 21.
And I can tap
8 p.m. browse sessions empty slot
on an item within that list. And if I want to move an entire page at a time, there's a gesture for, or
10 a.m.
moving
Wednesday,
up an entire page.
June 27th.
So these are the same accessibility actions that we use in BrailleBack. And there's something that you as a developer generally won't have to worry about.
So notice notice what Alan is showing there is a very, very powerful interaction model for completing tasks very quickly. So you can go, like, you use the Play Store all the time. So you know that the install button is approximately somewhere. So touching the screen and doing one flick is pretty much all it takes. Whereas, in ICS, you would explore, and then before ICS, you would have used the trackball. And so it makes the user interaction model really, really effective. And also notice that with what we have done, the access guidelines also change, where in the past, only things that could take system focus were visible to TalkBack before ICS, and we used to say, make things focusable. Now your life as a developer is a lot easier.
So as I mentioned, as a developer, you generally won't have to worry about this, except when it doesn't work. So you might wonder what receives focus when I'm moving my finger around the screen. Now, obviously, as a developer who's probably made layouts before, you may know that you'll have a lot of nested layouts. Obviously, these aren't all being read. So we're picking actionable groups. So actionable means clickable or focusable. And if you have a group like this folder icon that we're showing in the image, this is actually a group that contains an image and a piece of text. And because the group itself is clickable, it gets read aloud. Now, if it has a content description, then instead of its children being read aloud, the content description is read. And if you have an item that isn't actionable, and it doesn't have any actionable predecessors, obviously the only way that can be read is if somehow you can put accessibility focus on it. And fortunately, it will receive accessibility focus. So here's a hierarchy viewer view of what that folder icon looks like. So you can see that there's a folder icon, which is a view group, and that contains an image view and a bubble text view. In XML, that looks like this. So you can see the folder icon is clickable, thus making it an actionable group. And its children have two pieces of text. So the image view says folder, the bubble text view says Google. And when TalkBack receives puts focus on this actionable group, it will say folder Google. So some tips when you're designing your application. Make sure you use built-in widgets whenever possible. These things will just work because people have put a lot of thought into them. Make sure your app works with a keyboard or D-pad. So what we always used to say was make sure your app works with a D-pad. And if your app did work with a D-pad, fortunately, it will just work. You may have to make some changes if you were doing very special things. But for an application using built-in widgets, it will most likely just work. Make sure that you have readable content on actionable items. So if you have an image button, give it some text in a content description. And if you have a view group that's focusable or clickable, put some text in it or put some content descriptions on some of its child items. So here's an example of bad design and a way to fix that. So this is an orphaned actionable item. You have a frame layout that contains a view. This view is clickable, and it fills the entire frame layout. This text view, which has text, also fills the entire frame layout. And for a sighted user, this looks like a big button with the text label that you can click on, and that's how it performs. But to a service like TalkBack or BrailleBack, this looks like two separate items. So if you make the frame layout clickable and you put text inside of it, you have an actionable group and a child that will be read out loud. All right, so sometimes it gets a little bit more complicated than that. So let's say you've made this really awesome keyboard. And so here's what it looks like on screen. You've got a bunch of cool little buttons that you're rendering in code. So instead of having actual views for each one of these buttons, you're just drawing them onto the screen. Here's what the XML for that would look like. And as you might be able to guess, there's not much of a hierarchy there, not many actionable groups, nor many readable children. And you can fix that by providing more information to services like BrailleBack and TalkBack. So this is what it looks like without any changes to a blind user and to an accessibility service. It's just a big blank area. So fortunately, we have 3 steps that you can take. One is, in your custom view, handle incoming hover events. When accessibility is turned on and Explore by Touch is turned on, when you touch the screen, your view receives hover events. If you take a look at the Android source code for View, you'll notice that hover events get handled a little bit specially if accessibility is turned on. So here, because I know where I'm rendering the keys on screen, I can map the XY coordinates of a motion event to a key. I can say, was I just touching this key? If not, then I know that I need to send the appropriate accessibility events. So as I touch the key, I'll get a hover exit from the previous key, a hover enter for the new key, and TalkBack or BrailleBack will perform the appropriate, will say the appropriate speech for the key. Step 2, you need to populate that outgoing event. So you just sent a hover enter event. You need to tell it what key you were just pressing. So here I've made this send hover enter event for key method that takes a key, takes an event type, and populates the event with the information for the key. So that would obviously include things like text. And here I'm also setting the source. Because to get this great jelly bean functionality of being able to swipe and being able to double-click to activate things, I need a node hierarchy. So after I send my accessibility event, that gets to TalkBack or BrailleBack, and it has a virtual key ID. It can then query my application for the node info that's associated with that key ID. So here, I'm using a node provider, which I've taken out due to space constraints, but it has this create accessibility node info event that takes a key ID. I map that key ID to an actual key, and then I populate the node info with the key's properties. For consistency's sake, I'm also setting the parent of the node to be the keyboard that it belongs to, and I'm setting its source to be its own virtual key ID, and of course, its parent. So after taking these 3 steps, my keyboard looks the same to every user. So if somebody's using TalkBack or BrailleBack, if they put their finger on it, they'll receive the appropriate spoken or Braille feedback. And we don't just handle native Android views, we also handle web views really well. And Charles will tell you more about that.
Thank you, Alan. Hey, so I'm Charles Chen. I'm here to talk about web accessibility on Android. So Alan just gave you some really great advice on how to make native Android apps accessible, what you need to do, and how to do it. You can do the same thing if you're building a hybrid app. So if you're building a hybrid app that's a mixture of web content and native Java controls, you can make that accessible and make it work really well for users with visual impairments. So if you're using a web view just to do something really simple, really basic, for example, maybe display a terms of service, displaying instructions to the user, then that case is pretty straightforward. You have a web view, you put the text in there, and we'll just process it like regular plain text. Everything works, no problem, simple. On the other hand, if you're going to build something that's a little bit more dynamic, a little bit more Ajaxy, if you're going to use JavaScript HTML5 as part of your UI, you can still make that accessible, you can still do a great job here. All you really have to do is to follow the same best practices that you would do for a web app on the desktop. And the reason you do that is because on Android, we're running Android Vox. So Android Vox is a port of Chrome Vox. Chrome Vox is our screen reading solution for Chrome OS, runs on Chrome OS, Chrome. By the way, for those of you who are interested in hearing more about Chrome Vox, please come to the talk on Friday, Advancing Web Accessibility. It's going to be a really good talk, and I'm saying that not just because I'm one of the presenters. So, Rachel there is also going to be presenting, and as well as one of our other colleagues, Dominic. So please attend that talk, Friday, 11:30. Hope to see you guys there, please. Anyways, getting back to Android. So Android Vox is a port of Chrome Vox, and this gives you a lot of benefits. So all of the hard work that we've put into making Chrome Vox work really well on Ajax content, making it support W3C standards such as ARIA and HTML5, all of that goodness comes into Android, and it just works. And we've integrated this with Android so that the two experiences, both web content and native Android controls, blend seamlessly, and the users can just use your app, and they won't even really know the difference, and it will all just work for them in a single, simple experience. And so with that, I'm going to switch over to demo. Okay, and so it's usually helpful to get onto the demo app that I intend to show with web content.
Home.
So let me do that.
Home screen 3. IO 2012 WebView tutorial. IO 2012 WebView tutorial. Web content. Google I/O 2012 WebView tutorial.
Okay, so as you can see here, I have a hybrid application. This has web content near the top, and it also has Android controls near the bottom. And I'm going to touch the web content, and you'll see that touch exploration works the same way in a web view as it does for any native control. So I'm going to start touch exploring.
Accessibility for Android's WebViews is handled by Android Vox, a port of ChromeVox for Android.
Okay. Now, Alan earlier was showing you gestures where you could do swipes to do linear navigation. The same exact thing works here in WebViews. So I'm just going to do it.
The same best practices for building accessible websites apply for making WebViews accessible.
Okay, so now I've actually reached the end of this web content, and I want to move forwards. But I shouldn't really have to care about that as an end user. So I'm just going to keep navigating.
Previous button disabled.
Okay, so I've actually jumped out of the web content now, and I'm in the native Android control. Now I'm going to go to the next button and click it.
Next button.
Okay, and now I'm going to click.
Google I/O 2012 WebView tutorial.
Okay, so as you can guess from the heading here on this in the web content, this is probably not going to be a good slide. This is going to be something that's really bad. So here's an example of what you should never, ever do when you're making a hybrid application. This is an application that doesn't follow best practices, doesn't do the right things. So let's kind of go through it and see what's wrong with it.
Web content, bad, heading 1. Here is an example of a poorly authored page. This button is made up of div and span elements. It has no role set.
Okay, so I'm about to go to a button. It doesn't have the right settings on it. So this is, even though visually it looks like it's just a green button there, and it looks really pretty with 3D CSS, it's really just div and spans in there. It's not labeled as ARIA. It doesn't have any roles labeled for it, so the user isn't going to know that it's a button. There are no semantics backing it. It's just simple divs and spans. So let's see what happens when I go there.
OK, clickable.
Okay, so you know it's clickable because we could detect that there was a click handler there. But aside from that, you didn't really know if that's a button, a checkbox. What is this thing, right? You don't get any additional feedback. And that's because it wasn't properly set with a role attribute. Let's try clicking on this, though, because, hey, it says clickable. So what could happen, right? Let's see.
Clicked.
Huh. OK, I just clicked something. And I know I clicked it, but I totally missed that alert that came up. So let's see why that happened.
When this button is clicked, the alert region that is shown does not have an alert role set, nor is it marked as a live region.
So there are these simple HTML attributes you can add, and you can look these up. There is a W3C spec around it. But as Java developers, as Android developers, what you need to know is you need to annotate your divs and spans with attributes that give semantics. And when dynamic changes happen, you need to annotate those regions as being dynamically changeable, at which point whatever adaptive technology the blind user is using then knows to speak. In this case, the technology is, like Charles explained, is Chromebox. But this is not Android specific. This is basically good accessibility practice of the web.
Thanks, Raman. So that was some great advice. And again, if you want to hear more, please come to our talk on Friday. OK, let's move on to an example of where this is fixed.
Next button, Google I/O 2012 WebView tutorial.
OK.
Web content, good, heading 1.
OK, that heading actually sounds a lot more promising because it said good. So this should hopefully work. So again, I'm just doing swipe gestures to navigate. And these are the same swipe gestures as anywhere on Android. So
Here is the same page, but with the problems fixed. The button now has its role set to button.
OK, so now we've set the correct role for this button. Let's listen to what it sounds like now.
OK, button.
OK, so now this is working as intended. Now the user knows that this is an OK button. And they hear it, and it says OK button. So great. Let's try clicking it.
The OK button has been pressed. Alert.
Cool. So now I know that an alert has popped up, and it tells me the contents of that alert. Great. So it's working correctly, and that's because
the alert region now has its role set to alert, which is treated as a live region by default.
OK. And so with that, I'm going to switch over to testing on Android. OK, So testing for accessibility on Android is something that's really easy. It's as easy as 1, 2, 3. And there's really no excuse for not doing it because it's built into the system. So Alan here is going to help demonstrate just how easy it is to get accessibility up and running. And we know you all have devices now, so you really should get this done. So Alan?
Feel free to try this at home or in the audience.
Home screen, apps, settings.
So what Alan is doing here is he went into settings, he's going into accessibility, and he's going to turn on TalkBack.
Showing items 7 to 24, accessibility. Accessibility, navigate up. TalkBack on.
Okay, well, so normally you would turn on TalkBack and make sure Explore by Touch is enabled, and also enable additional scripts for web accessibility to ensure you get all the good.
Accessibility allowed.
To ensure you get all the Android Vox goodness. But since we already have this enabled, we're ready to go. So let's start testing it. Let's start experiencing what the user would experience. So the best way to do it is to just use your app.
Double tap to activate. Home screen 3.
And we're going to go into the Google I/O app.
Google I/O 2012. Google I/O 2012.
And just try to use it the way a user would, who's using TalkBack would be doing it. So use touch exploration to feel around the screen.
1:45 p.m. 2:44 p.m. Browse Code Labs empty slot now.
Okay. And
Captain Interface IO 2012 Brain Power FTW. Checkers out in after hours. Stream.
And take advantage of the great new gestures that we've added for accessibility actions. Use linear navigation. Try to move around your app. Try to scroll lists. See if it works, if it's going to do the right thing.
Android, Chrome, Code Labs.
Cool. So what we're really checking for here is to make sure that everything in our app can be done eyes-free. The user should be able to use your app whether or not they're looking at it. All critical information needs to be conveyed to the user. Anytime the user does some action, they need feedback. They need to know that they actually did the action, that it's working, that something is going on. Now, Android linting tools here are your friend. So earlier today, Raman mentioned that Android Lint has gotten a lot of good new features, and I think there's a talk on that later as well for Android tools. And one of these new features is the ability to do some really simple checks for accessibility. Now, this will not catch everything, but this is a really good starting point. And this catches a very annoying but simple to fix error, which is missing content descriptions. So if you run the lint tool with this command, as you see here, oops. So if you run the command, lint will actually catch cases where you have image views, image buttons that are missing content description. For a blind user that's using TalkBack or BrailleBack, all they're going to get is that there's an image there, but they'll have no clue what it is. So this is a really bad thing if that happens, and this will catch it for you. Now, you shouldn't be afraid to use this tool. It's not going to interfere if you have images that are just decorative, because if you have something that's purely decorative, that's not meant to convey any information, that's not actionable, it's not really meant to do anything, you can always tag that with the null notation. So if you set @null, then it will tell the tool to ignore it. It's only decorative. It's just eye candy. Doesn't really do anything. Now, if you do what we talked about here today, then you're going to build an app that's usable. But I would really like to challenge everyone here to go further, to go the next mile. Because it's not about just making things usable so you can kind of struggle through it. It's really about building apps that are great, building apps that people love to use. So really, I think we should all strive for building apps that are just as efficient to use eyes-free as it is looking at the screen. And with that, I am going to hand it back to Raman.
Thank you, Charles. So to wrap up, accessibility on the Android platform really helps you reach an ever-increasing wide range of users. The platform does a lot of work for you. But if you follow some of these guidelines that we are giving you and do some of the testing that Charles suggested, I guarantee you that not only will your apps be usable by blind users, by low vision users, by users of specialized interfaces, but you will in general discover that your user interfaces become more robust, they degrade gracefully, which means that your application just works in environments that you originally did not expect it to, and that's a very, very powerful thought. Accessibility is the law in many places. If you're selling to the enterprise, if you're selling to universities, your applications cannot be used if they don't meet certain accessibility requirements. But that's actually, in my opinion, the initial educational reason why you should be worrying about accessibility. In general, if you build your apps to be accessible, my own experience has been that those applications eventually end up being more usable for everyone. As an example, we last year in our I/O talk on accessibility showcased TuneIn Radio. I discovered that app 2.5 years ago, and I loved it. It was very, very nicely done. We found it was accessible out of the box. And today, that is one of the most used radio tuner applications on Android. So I think I'd love to see a lot more of those coming from each one of you. Thank you.
Also, before we go to Q&A, I just want to mention that we showed a lot of things here today, and I know you all are dying to see a Braille display in real life. So please drop by our sandbox. Our sandbox is just out in front here of this hallway. It's accessibility. You can't miss it. So please drop by and say hello. And also, we have partners here, and so come by and check it out. OK, and so with that, we'll go to questions. Thank you. Yes?
Yeah, with more complex items like multiple radio buttons in a group or like things that need to swipe to do an action, are we going to have to include instructions for what exactly is going on, which radio button is selected whenever, say, one is an option?
So if you're using built-in radio buttons, no. You can just let the built-in widgets do their job. For gestures, so as you may have noticed when I was doing regular scrolling, I was using 2 fingers. So when Explore by Touch is turned on, your 1-finger gestures simply become 2-finger gestures.
Yes, sir.
So my question relates to content descriptions. Let's say you had a list of items, say movies, and then when you entered it, you got an image of the movie's poster art, and then you had the title. Is it appropriate to make the poster a null content description? Should that somehow dynamically be sent, or just say this is a movie poster?
So I think in general, if you're going to add a content description, it should add meaningful information. So if you've already got the title of the movie, and the movie poster just reiterates the title, then you should probably avoid it.
Yes, and I definitely wouldn't like the thing to say movie poster, because that doesn't really give me that much more functionality as an end user. So err on the side of making your application less chatty in some sense. Right?
Thank you.
Yes. I think you had it first. So.
Yeah.
Okay, go for it.
I wanted to ask a question that swipe gestures that you showed today are not applicable for 4.0, right? It is available for only Jelly Bean, right?
Yes.
Correct.
Right, okay. Another question that I have is that typically for the standard objects, there is a fixed content description. Is it possible to modify that content description? For example, I'm using a WebView in my application, and whenever I launch WebView, it says WebView starting. And because I'm using into a, let's say, ebook reader, I want to say something else. Is it possible to do that?
So my advice to you is to actually not put a content description on WebView, because if you do, your content description will trump the normal behavior.
Okay.
So you'll actually lose all of our web handling abilities, and you'll end up having to re-implement the whole thing yourself, which is not what you want to do. So rather, you shouldn't do that. Instead, you should offer your page in a way that really follows HTML5 accessibility best practices, and it should just work. If you have more detailed questions about that, I'd be happy to chat with you one-on-one offline.
Okay.
and I'll look at your app. So.
Okay, thank you. Thanks a lot.
No problem. Yes, sir.
Hi. Look, just with a lot of apps, you often find that there's a sort of help guide to how to use the app, and this is not even in the realms of accessibility. Now, seeing how you stumbled a bit with getting to the send button in the was it the instant messaging demo that you made earlier? When you first found that program, did you have to sort of prod around to even know that there was a send button there? How can we make it sort of intuitive but accessible at the same time?
So you ask a very good question. So one way you can actually make it really intuitive for blind users is to keep things, have things appear in places you would expect. I give you an example of this from real life. Tonight, after the Google I/O party, you will all go back to your hotel rooms. And when you open your hotel room door, you do not hunt around for the light switch. The light switch is right there. And I personally would like to see touchscreen interfaces in the next couple of years develop that level of consistency where things are where you expect them to be. Today, for a blind user, touch exploration is our way out, so we explore. But that, as you observe, is painful. And in a world where things have sort of settled down, today in mobile space, we are all innovating very rapidly. And in some sense, all of the user interface controls are in different places depending on what the designer thought was best. But hopefully things will settle down where, a year from now, just as today you don't have to hunt for the light switch in your hotel room, you can find the OK button or the install button without actually hunting on the screen.
Okay, can I quickly add, do you think it would be a good idea if you opened your door to the hotel room and a voice said, there's a light switch to your right?
That would be a nice thing. But on the other hand, if it's always on the right, why do you even actually need to say that? Because for instance, supposing we built a system like that. We said every time you open the door, it says where the light switch is. What is a deaf user going to do? What is a deaf blind user going to do? Right? We end up, I think, consistent. It's not to say that these are mutually exclusive solutions, but user interfaces work best when you don't notice them. When you walk up to a door, the type of door handle tells you whether you should push or not. The door shouldn't say push me or pull me, right?
Also, I'd like to add that in your specific question, that's actually one of the really powerful ways where you can use touch exploration and linear navigation in tandem. If you remember during my demo, I did some touch exploration first on the web content, and then I started doing gesture navigation. And this is the same thing that works in any part of Android. You can touch explore to something, and then you can start doing gesture navigation from that point onwards. So the first time you use an app, it might take you some time to know where things are laid out. But once you figure that out, in the future, you can get into the general vicinity and then just use linear navigation to get there.
So for instance, on the phone today, when I run Chrome, I load CNN or BBC or whatever sites that I read news on often. I know that the top 1/3 of that page on that screen is navigational stuff and things that I would normally not need to read on a regular basis. So I approximately put my finger halfway down, hear a headline, and then say, OK, now read from here. So it's a powerful paradigm, but a year from now, as these things get consistent, hopefully I'm sure we'll be saying something more optimal.
Thank you. Yes, sir.
So we have the option to use JavaScript to mimic native gestures such as a swipe or a rotate. Now that you have the ability to use, to go from, normally a one finger would swipe or two fingers would rotate. Now you're saying that I can use 2 fingers to swipe with the touch feedback. Does that mean that web developers can continue using JavaScript libraries that mimic native gestures? Because that's normally been a problem.
Yes, so basically what's happening here is that as a developer, you don't really know the difference between, you won't realize that we're doing the 2-finger swipe thing What's happening is on the Android end, you get, you code it the same way as you would normally. And what you'll get for the end user is if they use 2 fingers and they have touch exploration on, you'll see 1 finger. So you won't actually see that difference.
So the answer to your question is you can continue using those libraries. And because we've done this consistently at a platform level, blind users of your application will know that, that they need to use an additional finger. So that 1 finger that we are using for touch exploration basically to the platform looks like a mouse pointer moving when accessibility is on.
Is there a way to easily detect if there's accessibility is on the device, and
Yes.
is it advisable to change your content if that flag is on?
So you can check programmatically, yes. We would, unless you're doing something that is really hairily custom, where you think you can actually provide better semantics, I wouldn't actually change the content. So for instance, if you have an extremely custom view, so Alan showed you the example of a keyboard, but let's say you develop like a fancy calendar app or something like that, and you have this custom canvas into which you have built your calendar model using a couple of lists, a couple of grids and whatever. And you feel as an app developer that by saying list, grid, and button, the semantics of your app are being lost, then you can basically implement your own accessibility bits just the way we do for some of the more complex platform widgets. But that's the level at which I would customize things. I would not sort of do a separate view or a separate content layer, because over time the two will go out of sync and you'll have problems.
It's very rare that you'll save time by implementing something separate.
Yeah, it only makes sense like if you were doing everything like OpenGL or something, and it's just a plain list, and you want to just have a
I should mention,
list,
though, if you use a node provider, you can make something that's written in OpenGL using a surface renderer or a GL canvas totally accessible, and it would be indistinguishable from a real view hierarchy if you implement the node provider correctly.
Yeah. So in general, don't try to do that.
So the extra code you would be implementing is what Alan and Charles described, which is the node providers and exposing. So you'd be exposing semantics through this virtual hierarchy.
Anyway, if you have anything more specific, we'd be happy to talk to you offline after this talk. Yes, and I think this might be the last question since we're running short on time.
Hi, my name is Daniel. Thank you for this session. When Peter sent to Alan the message in the presentation saying that he loves coffee, he managed to find the send button, but the device did not give him feedback that the message actually was not sent. We could see it, but we couldn't hear it. So Peter thinks he sent the message, but Alan is still waiting for it. So what was the error in the programming of the application, or what was the source of this not giving this important feedback? Message has not been sent.
That's a great question, actually. I think that it's a balance between, of course, giving too much feedback. In this case, we should probably have given a little bit more feedback. But you can always go back and check if the message was actually sent, if you really want to know.
I think it was also, when you do hit the send button successfully, it does say sent. And I suspect what happened here was we were all our concentration was more on doing a talk and over demos as opposed to real usage. But the messaging application does give you feedback when you send successfully. It doesn't give you feedback when you fail to send. And so lack of feedback there is feedback in some sense.
And also, I'd just like to plug one of our new accessibility events, Accessibility Type Announce. This is exactly the use case where that would have come in handy.
So type announce
we'll be upgrading that.
Is when you want your app to just say something. If you send an accessibility event with the type of announce, it will just get read verbatim.
Thank you. OK, so any last questions or no? OK.
One last plug. We're down the hall at the corner, accessibility booth. Come see us.
Thank you, guys, and look forward to your apps.